Somewhere behind the German front line, in a workshop that smelled of oil and cold metal, a mechanic opened a wooden crate taken from a captured American convoy. Inside was a part. He set it against the machine on his bench, and it went in. He did not have to file it, or scrape it, or reach for a shim. It went in the way a key goes into a lock. He had spent his working life learning how to make parts fit. A factory 6,000 kilometers away had just told him the skill was no longer required. This was not luck. It was not a better machinist standing at a better lathe. And it was not, whatever both sides would later claim, one nation being cleverer than the other. What that mechanic was holding was the end of an argument about human skill that started in American gun factories more than a century before the war began. Germany had heard the argument. Germany had rejected most of it. By 1944, that decision was destroying German tanks faster than the Allies were. To understand why the part fit, we have to look at the men who were trained to make parts fit by hand, at the strange American obsession that made those men unnecessary, and at the moment on the Eastern Front when German craftsmanship stopped being an advantage and turned into a problem nobody could repair. In 1939, German engineering was the standard the rest of the world measured itself against, and it had earned that reputation honestly. A German factory floor was built around a specific kind of man. He was called a Facharbeiter, a skilled worker, and he came up through an apprenticeship that ran 3 or 4 years under a Meister who signed off on his competence the way a guild had done for 600 years. He could read a drawing. He could feel a few microns with the back of his thumbnail. He could take a part that was wrong and make it right. That last ability was the pride of German industry. It was also the thing that would destroy it. To see why, you have to understand what the word fit actually meant on a workshop floor in 1939, because it did not mean what it means now. When a bearing cap was scraped to a crankshaft, the mechanic was not installing a part. He was finishing one. He would coat the surface with engineer's blue, set the cap down, lift it, and read where the color had transferred. High spots. He took them down with a hand scraper a few microns at a stroke and did it again and again until the blue came up evenly across the whole face. And then that cap belonged to that crankshaft. It fit nothing else on earth. That process repeated across the entire machine. Valves lapped into their seats with grinding paste, pistons measured and sorted into groups and matched to the bores that suited them, shims stacked to close a gap the drawing had never quite predicted. A German tank engine was not an assembly of parts. It was a negotiated settlement between a few hundred pieces of steel and the men who had persuaded them to live together. Which meant a spare part inside the German system was not really spare. It arrived close to size and a man made it correct. That worked beautifully, as long as you had the man. There is a detail buried in that last sentence that decided more of this war than most of its battles did. 6,000 kilometers west, in a country with almost no guild tradition and a permanent shortage of trained hands, a different answer had been worked out slowly and painfully across the previous 100 years. The version that made it into schoolbooks involves Eli Whitney, a table covered in musket parts, and a demonstration for the American government in 1801. It is a good story. Historians have spent decades taking it apart. Whitney's parts were reportedly selected in advance for the demonstration. His contract ran years late, and genuine interchangeability never really came out of his shop. The real work happened somewhere far less famous. At the Federal Armory at Harper's Ferry, a New England gunsmith named John Hall spent the 1820s chasing something nobody had achieved. Rifle parts made in quantity that would fit any rifle without a fitter. Hall's breakthrough was measurement. He built a system of gauges, a master gauge that never left the office, working gauges checked against the master, and inspection gauges checked against the working gauges. Every part was made not to match another part, but to pass through a gauge. Go and no go. If it went through the first and would not go through the second, it was correct, and nobody ever had to look at it again, anywhere, ever. That is the whole trick. It sounds like paperwork. It is arguably the most consequential idea in the history of manufacturing, because the leap is not mechanical. It is conceptual. A craftsman makes a part fit a machine. A gauge makes a part fit a number. And a number can be put on a piece of paper and sent anywhere in the world. By the time America entered the Second World War, the country had been organizing itself around that idea for 4 generations. The Society of Automotive Engineers, SAE, had spent decades hammering out common specifications for steels, for threads, for the shape of a bolt head. A national commission had settled the screw thread question after the First World War, when American industry discovered that its own factories could not reliably bolt to each other. Tolerance, limit, fit class. Those are not exciting words, they were the foundation the American war machine was built on. And you can see the whole argument in one vehicle. The Jeep was designed by Willys Overland. It was also built by Ford. 2 rival companies, 2 separate factories, and one government with no interest whatsoever in whether they got along. Ford was ordered to build the Willys design, to Willys drawings, so that a component coming off a Ford line would drop into a Willys chassis without complaint. Ford stamped its own letter F into its parts, which is how collectors tell them apart today. That letter is the only difference that mattered. More than 600,000 Jeeps were built. A mechanic in Normandy pulling a part out of a box did not need to know which factory had made it, or which factory had made the vehicle it was going into. He did not need to know because of the number stenciled on the box. This is the part of the American system that gets almost no attention, and it is the part that won. The United States Army Ordnance Department ran a catalogue. Every part on every vehicle had a name, a stock number, and a page. The standard nomenclature lists filled shelves. A clerk in a depot in England could pull a number off a page, and a mechanic in a field workshop in France could push that part into a truck, and neither man ever had to speak to the other, or to the engineer who drew it, or to the woman in Michigan who machined it. The German system moved skill to the part. The American system moved information to the part. Skill does not travel, information does. Now Germany was not incapable of any of this, and the claim that it was gets repeated constantly and is simply wrong. Germany had one of the most thorough standards organizations on the planet. DIN, the German Standards Institute, had been publishing since 1917, and its work was so complete that the rest of the world still uses pieces of it every day, down to the size of the paper this script was printed on. The Opel plant that built the Blitz truck was running an assembly line laid out by General Motors, which had owned Opel since 1929. The Volkswagen works at Fallersleben was modelled on Ford's River Rouge. German engineers had gone to Detroit, taken careful notes, and come home impressed. The problem was never that Germany could not make identical parts. The problem was that Germany was making far too many different things for identical parts to save it. One man saw it, said so, and was handed the job of fixing it. His name was Adolf von Schell, and in 1938 he was made responsible for German military motorization. What he found was a catalogue of vehicle types that had grown to well over 100 because every manufacturer had built its own designs and the army had cheerfully bought them all. Schell's plan was blunt: kill most of them, cut the truck types down to a handful, and force the survivors onto common components. It was the correct answer. It arrived late and it never fully took. Manufacturers protected their own designs. The army kept its exceptions. And then Germany won in 1940. And winning made everything worse, because a conquering army inherits the loser's motor pool. French trucks, Czech trucks, Belgian and Dutch and Polish ones, and later Italian and Soviet. Every one of them a different bolt, a different bearing, a different drawing, sitting in a factory that was now on the wrong side of the war. Logistics historians working through the records describe a German army that went into the Soviet Union in 1941, operating something on the order of 2,000 distinct vehicle types. That figure gets repeated with more confidence than the sources really support, so hold the exact number loosely. The pattern underneath it is not in dispute. Every one of those types needed its own spare parts, its own drawings, and its own man who knew how to make them fit. If this is the kind of history you came here for, subscribe. The archive grows every week, and that is the only thing keeping it growing. While all of this was being decided in committee rooms and on factory floors, a second war was already being fought, and it does not appear on any of the maps. So the mechanic in that workshop was not stunned because the American part was made better. In a great many cases, it was not. American tolerances on a given component were often looser than German ones rather than tighter. A Maybach engine block was, by any measure a machinist would recognize, a finer object than what came out of a Chevrolet plant in 1943. He was stunned because the American part did not need him. That is the answer, and it runs backwards through almost everything the two armies believed about each other. German design assumed that skill would be present. It assumed a Meister in the workshop, a trained hand on the line, a man who could look at a component that was a hair out and make it right before lunch. That assumption was not arrogance. In 1938, it was simply true. American design assumed that skill would be absent. It assumed the man holding the part would be 20 years old, trained in a matter of weeks, working in the rain, in the dark, in a country he could not find on a map, on a vehicle he had never seen before, with a component made by a factory he had never heard of, and that nobody within 400 kilometers would know anything he did not already know. So the part was designed to work anyway. One of those assumptions survived contact with the Eastern Front. The other did not. By 1943, the Meister was frequently not there. He had been conscripted, or he was dead, or the workshop was 200 kilometers behind a line that was moving the wrong way, or the vehicle on the ramp was a captured Renault that nobody in the unit had a drawing for. The German system had one component it could not replace, and that component was a man. And notice what that does to the word interchangeable. Underneath the machining and the gauges, the argument had always been about people. A country that can interchange parts never needs to interchange men because it never needed exceptional men in the first place. A country that cannot has to find another Meister every time it loses one. By 1943, Germany was losing them faster than it could make them. Men are the hardest thing in the world to mass produce. The results turn up where you would expect, which is in the recovery reports rather than the battle accounts. Across the retreats of 1944 and 1945, an enormous share of German armoured vehicles were lost without ever being hit. They broke down, or they ran dry, or they could not be towed out in time, and their crews burned them and walked away. The exact proportion is argued over, and probably always will be. The direction of it is not. It is what the German army's own returns say, and it is what Allied recovery teams found when they walked the ground afterward. The Panther is the case everybody reaches for, and for once, the cliché has earned its place. When the Panther went into its first large action at Kursk in July of 1943, roughly 200 of them rolled out. Within days, the number still running had collapsed to a fraction of that, and a great deal of that loss was mechanical rather than enemy action. Final drives and engine fires, mostly. The figures bounce around in the returns as tanks were repaired and then failed again, which is, if you think about it, the entire point. Germany had built one of the finest fighting machines of the war and then spent the battle watching it sit still. A tank that cannot be repaired is a pillbox with an expensive engine in it. And the men in those workshops were not incompetent. They were the opposite of incompetent. German field mechanics did recovery and repair work under conditions that would have been called impossible in any peacetime factory, with improvised tools, cannibalized wrecks, and no supply of the parts they actually needed, and they kept units in the field long past the point where the arithmetic said those units should have stopped existing. Their skill was real. By 1944, it was also the only thing holding the system together, which is another way of saying the system had already failed and simply had not been told yet. None of which made the American system elegant. It was not. The M4 Sherman was built by something like a dozen manufacturers with interchangeable hulls and turrets, and then fitted with 5 substantially different engine types, which meant the American Army spent the war maintaining a tank that came in several incompatible flavors. When American and British units tried to share tools and hardware, they discovered that their threads did not match because Britain had standardized on Whitworth and America had standardized on SAE, and no amount of alliance would make a bolt turn that did not want to. The two countries, along with Canada, only sat down and agreed a unified thread standard in 1948, after the shooting stopped, because the war had made the cost of not doing it impossible to ignore. Interchangeability was never natural. It was fought over, legislated, argued about in committee, and paid for decades in advance by people who had no idea what it was going to be for. Which brings us back to the workshop, the crate, and the part that went in without a fight. We should be honest about that scene. There is no single document behind it, no named mechanic, no moment anyone can date. What exists instead is the same reaction surfacing over and over in post-war interrogations, in technical evaluations of captured equipment, and in the recollections of men who had spent their working lives with a scraper in one hand. The individual story is a reconstruction. The pattern is not, and the pattern is what matters. Because the thing that beat those men was never a better tank or a bigger factory. It was a wooden box with a number stenciled on the side, sent by a country that had decided, 100 years earlier, that skilled hands were too scarce and too slow to build a nation on, and had spent the century since building a system that did not require them. Germany bet on the craftsman. In 1938, that was the better bet. By 1942, it was the wrong one, and the man in that workshop understood it about 3 seconds after the part slid home. He was not looking at a piece of steel, he was looking at the shape of the rest of the century, and there was nothing in his toolbox that could file it down to size. If you want the other half of this story, the one about how many of those boxes America was able to send in the first place, that video is on the channel now.